Hey guys, what's up? Felipe here. So as you know, I'm here to keep you up to date with current market news, teachings, and everything tech. So in this video, I'm going to be we're talking about Go language, Golang, which is pretty cool language, and specifically concurrency in Go, right? So one of the popular features of Go language is the first class support for concurrency or the ability of a program to do multiple things at once. So two features in Go. Go routines and channels make concurrency easier when used together. A Go routine basically solves the difficulty of setting up and running concurrent code in your program, and channels solve the difficulty of safely communicating between code running concurrently. Go routines cannot have returns, but when combined with channels, you can kind of work that in, but that is something for later on. So basically, in modern computers today, the processor, right, the CPU is designed to run as many streams of code as possible at the same time. So these processors have more than one core, and each of these cores are capable of running one stream of code at the same time. So the more cores your program can use, the faster your program is going to run, right? Just logically. So what are Go routines? A Go routine is a special type of function that can run while other Go routines are also running. When a program is designed to run multiple streams of code at once, the program is designed to run concurrently. So the power of Go routines basically provides is that each Go routine can run on a processor core at the same time. If the computer has four processing cores, that basically means your program can have up to four Go routines. All four Go routines can run simultaneously when multiple streams of code are running at the same time on different cores like this. It's called running in parallel. So another cool thing about Go, or one of Go's powerful traits, is scalability. A program is scalable when it can run on anything from a small computer with a few processing cores to a large server with dozens of cores, and basically take advantage of all those additional resources. So with that being said, let's kind of jump in here and play around with this, or what it looks like. Whenever you're gonna play around with Go or start a project or something, one of the things you're gonna do is run a Go init, and you pretty much name this. Well, actually, it's Go mod init. Go mod inits, and I don't know, Go routines. So Go mod inits, Go routine. All right, sweet. So now we should have a go.mod in there, and then lastly, I'm just gonna touch a main.go, and let's jump in here. All right, so this is just gonna be package main right there. So I'm just gonna give a quick example of not using Go routines, and then we'll use Go routines. So quick example here. We're just gonna initially see what it looks like without using Go routines, and then we'll kind of play around with some Go routines. So and of course, we're gonna need a function, a main function, func main, blah blah blah. I'll just leave it like that for now. Let me just close that over here. Okay, so let's see. We're gonna have a func generate numbers that takes in a total, which is a int. And then we're going to do a loop in here for IDX for index equals 1. As long as the index is less or equal to the total that we pass in, we're going to increment the number, right? And we're just going to print it. So there we go. This AI auto generator thing is annoying sometimes. So we're just going to do an FMT print with the index there, and we're just going to add a comment here, generating number percentage D for the digit, and then new line, boom, and then it's the index there. Okay. Um, and then we're just going to have another number called func print numbers, just to print some numbers over here. And then we're just going to do kind of the same thing. So we're going to do a for index equals 1, as long as the index is less than whatever number you want to put here. I'm just going to put 3. We're going to increment, and then we're just going to print this with fmt.print f printing number percentage D, new line, and index IDX. All right, so now to the main function, all we're gonna do here for now is just basically that, right? We're gonna call the generate numbers function and then the print number function, and then we're passing a number 5 for the total into the generate numbers. So that means it should do that 5 times, right? Because total is 5. So let's go ahead and save this and run it. And then this is just not using we're not using go routines yet. So we're gonna do a go run main, boom, and then boom, it just prints out generating numbers 1 through 5, printing number 1 through 3. So in this program, basically these two functions are independent of each other because they don't rely on data from one another to run. So you can take advantage of speeding this up hypothetically by running functions concurrently using Go routines. That's where now we're going to go into Go routines and kind of see examples of that when you're running both functions, or when both functions are running concurrently. The program could, in theory, run in half the time, right? Because now it's not waiting for something else to finish before the code runs. It's just running concurrently, which is beautiful. So for the program to run the Go routines concurrently, you'll need to, we'll basically make some changes to the functions we just wrote. So if you don't wait for the Go routines to finish and your main function completes, the Go routines can potentially never run. So we're going to use a library to kind of work that in. So what we're going to do is we're going to use wait groups, which are from the Go sync package. The sync package basically contains synchronization primitives such as wait groups, which is what we're going to use, that are designed to synchronize various parts of your program. The synchronization keeps track of when both functions have finished running, so the program can exit, right? Because otherwise, possibly the Go routine will never run and so forth if it's not waited, right? So the wait group primitive works by counting how many things it needs to wait for using certain methods it comes with, which is add, done, and the wait function. The add function increases the count by the number provided to the function. The done decreases the counts by 1. The wait function can then be used to wait until the count reaches 0, meaning that the done has been called enough times to offset the calls to add. Once the count reaches 0, basically it's done, and then the wait function will return and your program will continue running. So let's kind of do some alterations here to add that. So we're going to need the sync package. So we're just going to import sync right here so we can use the wait groups. And basically now we're going to just go into the main function over here, and we're going to create a variable Oh my goodness, this AI stuff kind of sometimes does it all for you. So, well, that was pretty much what I was going to do. So we're going to create a variable WG, which is the sync.wait group. And then we're going to use that same variable WG.add. So we're using the add method two because we're going to have we're going to add two go routines, right? One for the generate numbers function and one for the print numbers function. So basically all we're going to do here is we're going to add a go in front of each of these functions. And then we're going to pass in a reference to the wait group. So WG, boom. And then we're going to do a WG here. And then I'm just going to do a print here, print ln waiting for go routines to finish. And finally, we're going to do the W dots wait to wait for all those go routines to run. And then we'll just do a print ln here saying it's done, right? So now we go into these functions, right? And the first thing we need to do is we're going to pass in the wait group. So we're going to pass this in sync dots wait group. And we're going to pass it in over here too on the generate numbers function, which I forgot to pass the number here. We'll just do a 3. And then we'll just do the same thing up here. We're going to pass in the wait group. So it's going to be a WG pointer sync dots wait group with a capital letter. There we go. This thing's new and I'm gonna disable this AI stuff. It annoys me. So basically, we're just gonna do a defer WG done, which waits for everything in the function to run, and then it comes back to the defer, and then it's gonna run the wait group done method. We're gonna do the same thing in what is this? Unused, yeah. So we're gonna do the same thing here. A defer wait group done. And we're gonna save this and we're gonna run it. Just clear that. And then you're gonna see that it's not gonna run in the same sequence that it did prior the first time we ran it. So now ran in a different sequence, right? So basically after declaring the wait groups, the wait group basically it needs to know how many things is going to wait for, right? And that's what the add function is. We passed in 2, so it's basically saying, hey, wait for 2 go routines in the main function before it would tell the wait group to call the done methods, right? Or the 2 done methods will be called before considering the group is finished. This isn't done before go routines are started. It's possible things will happen out of order, or the code may panic because the wait groups doesn't know it should be waiting for any done calls. So each function will then use defer to call done to decrease the count by 1. So decrease the add function, the add method count by 1 each time the done method is called. After each of those functions are done running, right? The main function is also updated to include a wait method on the wait group. So the main function will wait until both functions called done to continue running and exit the program, because otherwise the program is just gonna run, right? Or the go routines may never execute because it's just gonna exit out of the main function too quickly. So we also use the sync.wait group, which is what we saved in the var variable down there, to make the program wait for the go routines to finish before exiting the program. So in Go routines aren't able to return values, which is kind of what I was saying. And basically what makes a something a Go routine is just using the Go keyword in front of it, kind of like what I did here with generate numbers and print numbers in the main function. That makes it a Go routine, which pretty much any function you can make a Go routine. And if you notice, there's no return values inside of those functions because Go routines cannot return values. To do that, you have to add in channels, right? And then that's a later topic to kind of not to keep this not so long-winded. But this is basically Go routine. This is pretty cool stuff. And it's an example of concurrency, which is a pretty cool thing about Golang. And yeah, with that being said, thank you guys for watching. If you found this interesting and want like to see more, stay tuned. I'll make a next video kind of going over concurrency and how that looks and how that works and combine it with what we just did here. So I'll see you on the next one, and thank you for tuning